Hello everyone, welcome to the video explanation for Brian Passwater's Topic 3-8 Notes, Example 1. Example 1 reads, a portion of the function f is shown above. The function f can be written as f of x equals a times the tangent of bx plus d, where a, b, and d are constants. Find the values of a, b, and d. So we've talked a bit about tangent function in the notes already. We know that several things apply here. The midline of the tangent function is the horizontal line that passes through the inflection points of the graph, where it switches from concave up to concave down. So those 3 points are located here. That line is the line y equals 0. Now the midline of that graph is always y equals d, which means that our d value here on this graph should be 0. The tangent function always passes through 3 very, very specific points. When we look at those points on this particular graph, that allows us to figure out the amplitude, because the amplitude would be the absolute value of the distance between the inflection point and this next point up. So if we're looking at that distance is 1 unit, whether we go up to that point or down to the point under it, it is equal to 1. So the absolute value of our A is 1 unit. And since the tangent waves are increasing, okay, since our end behavior is going from low to high on each of our tangent waves, A is greater than 0. So we know that A is equal to positive 1. And then finally we have the period. Now the period of the tangent function is equal to the absolute value of pi over b. Now again, we're generally going to be trying to avoid a horizontal reflection, so we really are more interested in making sure we can look and see that the period would be the distance between any of these vertical asymptotes. So if we look at the distance between any of these vertical asymptotes, 3 pi over 4 minus pi over 4 is 2 pi over 4, meaning that that distance is pi over 2. Same thing here, pi over 4 minus negative pi over 4 is 2 pi over 4, or pi over 2. So each of these vertical asymptotes is pi over 2 apart. So that would be our period. Our period would be pi over 2, which is equivalent to the absolute value of pi over b. And if we look at that, we can very quickly see that b is 2. So there we have it. Our a value is positive 1, our b value is positive 2, and our d value, for example 1, is 0.